Welcome to Indefinite Integrals Lesson 4, Tabular Integration, where we try to make integration by parts somewhat easier? Kinda? Yeah, I know. Alright, so let's go on and show you what's going on here. Alright, now with this integration by parts deal, what you got is, okay, if you did your first f would be x squared, and g prime would be, e to the 3x, and when you would take the derivative of f, you'd get 2x, and you'd get g being e to the 3x over 3, but then you'd have 2x times, 2x times the integral of e to the 3x over 3, and then you'd have to do by parts again. So what we're going to do is we're going to put it in a table and see how it works, and we'll watch, and it will actually work for us. X squared, derivative of x squared is 2x, the derivative of 2x is 2, and of course the derivative of 2 is 0. If g prime is e to the 3x, the antiderivative is e to the 3x over 3. And then the antiderivative of that is e to the 3x over 9. And then the next antiderivative is e to the 3x over 27. Okay, after we find the derivatives and antiderivatives, we'll write down this column. You're going to start with a plus, and then you're going to go minus, and then you're going to go plus, and then you're going to go minus. And I don't want to explain it any more than that. If you want to know why these pluses and minuses go back and forth, ask me tomorrow in class, and I'll tell you. But for right now, just do it. Alright, now we're going to draw some diagonals here, right here, and right here. So our antiderivative, our integral is going to be here. Let me write this below so that you can see all of it, or hopefully you can see all of it. It's going to be x squared e to the 3x all over 3 minus 2x e to the 3x all over 9 plus 2e to the 3x all over 27 plus an arbitrary constant c. And that, folks, is really and truly the integral. Okay, what am I doing with these lines? I'm multiplying these together. That's where I got these from. Multiplying these together, the diagonals. And that's doing integration by parts in a shortcut method. Let's try another one. Okay, e to the 2x cosine of x dx. Okay, let's take the derivative of e to the 2x. That would be 2e to the 2x. The antiderivative of cosine is sine x. And then we'll go ahead and take the derivative of this again, and we get 4e to the 2x. And this would be negative cosine of x. And look at that. Right here, we have the same thing all over again. And if we kept on doing this in a table, it would keep on flipping around so that we end up almost having the same thing. So what we're going to do is we are going to go plus, we're going to go minus, we're going to go plus. Then we're going to make some diagonals. We're going to make some more diagonals. Now we're going to multiply those. So it is going to be sorry about that, e to the 2x sine x okay, negative and negative, that would be plus 2e to the 2x cosine x. We're going to put that in parentheses. We're going to look at this coefficient down here where you get to the point where the e to the 2x and the cosine x, that's what you started with. Even though this is negative, we'll ignore the negative sign. We're going to take that 4, we're going to add 1 to that and get 5, and we're going to have 1/5. So if this were like a 9, it would be 1 over 10. If this were a 7 here, this would be 1 over 8. Okay, that's how that will work. And then don't forget your arbitrary constant c. And there you go. This is called recursive when it comes back to the same exact function again. And if you kept on doing it, it'd just be in a big loop. We don't want to get stuck in those big loops. Alright, let's try this again. 3x minus 1 cosine of x. The derivative of 3x minus 1 is 3. The derivative of 3 is 0. The antiderivative of cosine is sine x. And the antiderivative of sine x is negative cosine x. And we're going to go plus. So we're going to go minus. We're going to go plus. Then we're going to go down diagonal. And we're going to get 3x minus 1 times cosine of x plus 3 cosine of x plus an arbitrary constant c. Wow, Mr. Manning, why didn't you show this earlier? You know how mathematicians are. We got to show you the hard way and the long way and then give you the somewhat easier way. Oh, by the way, Brian, you're not going to get a shout out, so don't worry about it. Hey, wait a minute. Is that a shout out? I don't know. Alright, e to the negative 3x sine x. Once again, we're going to have a little nice recursive loop here. So let's take the derivative, negative 3 e to the negative 3x. And then take another negative 3 out front, 9 e to the negative 3x. And the antiderivative of sine is negative cosine. And the antiderivative of negative cosine is negative sine x. And then we're going to go plus. And then we're going to go minus. And then we're going to go plus. We'll draw our two diagonals. Just like that. And the integral is negative e to the negative 3x cosine of x. Okay, we've got a negative and a negative and a negative. 3 negatives multiplied together, minus 3 e to the negative 3x sine x. Put that all in parentheses. And we're going to multiply it by, there's that 9. Add 1 to that, 10. 1/10. And don't forget the arbitrary constant, c. By the way, this was number 8 from your homework, just a minute from yesterday. This one right here was number 4 from your homework, and the one that we did before that, that example, that was number 3. That was number 3 from your homework, and then the next one, number 4, number 8. Hey, let's go ahead and do number 10 from your homework. Let's do that tabular as well. You were trying to find the integral of x squared e to the 3x dx. Here's your f, here's your g prime. F is obviously x squared. G is e to the 3x 2x e to the 3x over 3 2 e to the 3x over 9 and one more, 0 e to the 3x over 27. And we're going to go plus, and we're going to go minus, and then we're going to go plus, and we're going to go minus. We'll make our diagonals. So our final answer, our integral, will end up having a result of x squared e to the 3x over 3 minus 2x e to the 3x over 9 plus 2 e to the 3x all over 27 plus an arbitrary constant. This does conclude Indefinite Integrals Lesson 4, Tabular Integration. Integration by parts, somewhat easier. Goodbye.